Hi guys, in previous videos we have talked about different ways to solve systems of linear equations. We have talked about how to solve them by graphing, by using the substitution method, by using the elimination method, by using matrix inverses. That's where we set up a matrix equation and then use a matrix inverse to solve it. And then what is this? 1, 2, 3, 4, 5. For our final technique, we're gonna solve it. We're gonna solve systems of equations by using Cramer's rule. Cramer's rule is pretty neat. We can use it to solve any system, but the only catch is that it says Cramer's rules can use to be solved any size linear system as long as there is the same number of equations as variables. So for example, if we had x plus y equals 3 and then y plus z equals 5. So in this case, we have a total of 1, 2, 3 variables. 3 variables, we're expected to have 3 equations. We don't have 3 equations, so we wouldn't be able to use Cramer's rule. It's okay, we can use another strategy. Okay, so the question is, how do we solve a system of equations by using Cramer's rule? What if we have a system of equations in 2 variables, so a 2 by 2 matrix, whatever. So if this is your question, that's your system, then this will be your answer. Okay, we have 2 variables, so the solution, if we have any, will be the ordered pair x, y. That's nice, but the question is, well, how do we find x? How do we find y? To find x, you're gonna take dx divided by d, whatever that is, and then to find y, you're gonna take dy divided by d, whatever that is. But now it's time for me to tell you whatever that is. First, I'm going to focus on D, the one without the subscripts. So D, what that is the coefficient matrix. So the matrix formed by the coefficients in the system. So we have D, the determinant of the coefficient matrix. So the coefficients are, let me highlight the A's and highlight the B's. Okay, so for the first row, the coefficients are A1, B1. That's what we have right here. And in the second row, we have A2, B2. So we use D to remind us that we have to find a determinant. So D is the coefficient matrix. Okay, cool. What is dx? So dx is the determinant form when we replace the dx. The determinant form when we dx is the determinant form when we replace when we replace the x column values with the answer column values. Okay, so in this case, the only thing we change are the x column values. The y column value stays the same, so we take the determinant. What is dy? Dy is a determinant form when we replace, I feel like that's like a tongue twister for me. Okay, dy is a determinant form when we replace the y column values with the answer column values. So notice how we didn't touch the x column values. Okay, so D is the determinant of the coefficient matrix. Dx or dy, replace the x column values or the y column values with the answer column values. Cool. So now the question is, how should we attack this? So ultimately we need to find D, dx, and dy, but I'm gonna try to save you some headache. To find x, we find dx and divided by d. To find y, you will need to find dy and divided by d. The worst thing you can do to yourself is find d, dx, dy, and then later realize, like, shoot, you can't use this technique. So my recommendation is first find D. Okay, find the determinant of the coefficient matrix. I know that you know that division by 0 is not defined. I didn't write it out. Okay, so division by 0 is not defined. So if the determinant of the coefficient matrix is 0, then just stop right there, nip it in the bud, and then find another technique. You can solve it by whatever technique your heart desires. Now, how do we use Cramer's rule for systems in 3 variables, for 3 by 3 matrices? It's gonna be the same thing. Okay, but in this case, since we have a system in 3 variables, the answer is not gonna be the ordered pair x, y. It's gonna be the ordered triple x, y, z. And how do we find that? So x is given by dx over d, y is given by dy over d, and z is given by, you guessed it, dz over d. But the question is, well, how do we find these things? So same, it's going to be the same speech as for the systems and two variables. Okay, so d is always the coefficient matrix. Okay, so the coefficients of row 1 is a1, b1, c1, and then you can read the rest for coefficients of row 2 and row 3. So whatever the determinant of the coefficient matrix is, that's d. So again, if you want to save a lot of headache, find d first. Hopefully it's not 0. If it isn't, then go ahead, take the green light and find dx, dy, dz. If the determinant of the coefficient matrix is 0, save yourself a lot of headache and then go straight to another technique. So now, how do we find dx? Same way that we did before. We are going to replace the x column values with the y column, with the answer column values, my mistake, and then find the determinant. Okay, so remember, d is for determinant. Okay, now dy, we're gonna replace the y column values, and if you need to, I wasn't planning on doing this, that's why I don't have my pen ready. If you would like to put x, y, z to remind you which one you're replacing, you know, go for it, do what you gotta do. Okay, so dy, how do we find that? We're going to replace the y column values with the answer column values and then take the determinant. Dz, let's go ahead, take the z column values and replace it with the answer column values and then take the determinant. So that's like a lot of subscript notation and all that good stuff. Let's go ahead, put it into practice. Bear with me. Alright, so we're going to do a total of 4 problems because what do they say? Practice makes perfect. If I had time to do 100, I would, but who would sit for 100 problems? No, not I. Okay, let's do this. So we're not given the liberty to solve this system however we like. We are asked to use Cramer's rule. So we're going to try to use Cramer's rule, and if it's not possible to solve by using the specified technique, then I guess we have no choice than to use another technique. It says write the value of each determinant used. The reason why this is underlined is because this time around you have the green light to use a graphing calculator if you like to find a determinant. So because I know that you can use the graphing calculator to spit out the determinants, this is why I need you to explicitly write what the determinant is. Okay, so let's go ahead and do this. So first of all, let me remind myself of what the answers look like. We have a system in 2 variables, so if a system has a solution, then it's gonna be the ordered pair x, y. How do we find x? We're gonna take dx and divide it by d. So again, they're gonna be determinants of specific matrices. And then to find y, we're gonna take dy and divide it by d. Again, they're determinants of specific matrices. Again, if you love yourself, I need you to find the determinant of the coefficient matrix first. Okay, and if that is not 0, then go ahead, invest your time and find dx, dy. Cool. So d, okay, so that is going to be given by the determinant of the coefficient matrix. Coefficients of the first row is 5, 2. Coefficients of the second row is 2, -3. Fantastic. Yes, you can use a calculator, but check it out. Since we have a matrix, a 2x2 matrix, it may be a little bit faster if we freehand it. So let's do this. So let's go ahead, take the cross products and subtract. Okay, so first cross product gives us -15. And we're going to subtract from it the other cross product, which gives us 4, and that will give us -19. This is good enough for me, but as a student, I think me having d equals work equals -19 is a little bit tough on the eyes. So let me go ahead, put a semicolon and then write it down, so that way I can see right away, oh yeah, the determinant of the coefficient matrix is -19. That doesn't equal 0, so that makes me happy. Okay, so that means I can use this technique. I can use Cramer's rule. Okay, so let's go ahead, find dx. So the dx is the determinant form when we replace the x column values with the y column values. So what I like to do is I like to use a highlighter on whatever I'm replacing. Yeah, that didn't look so nice. So we're gonna replace the x column values with the answer column values. So in this case, the answer column values is -1, 2. Okay, -1, 2, and then the y stays the same. Something that I like to do, I like to put a xy when we were finding the determinant of the coefficient matrix. That way it's easier for me to look at just the numbers versus the original matrix. So we're only changing the x column values, so the y column values will stay the same. So again, same speech, if you want to punch it in because we have the green light, go for it, but it may be easier just to freehand it. So the first cross product, namely -1 and -3, that should give us 3, and we're going to subtract from it the other cross product, which is given by 4. Difference of 3 and 4 is -1, and if you love yourself, go ahead and write it again. So we have the dx, or the determinant form, when we replace the x column values with the answer column values, gives us -1. So we found d, we found dx, now we need to find dy. I'm going to go ahead and use a different highlighters. Hopefully there's not so much bleeding. Okay, so dy is the determinant form when we replace the is the determinant form when we replace the y column values with the answer column values. So let me go ahead highlight it so you know which one is getting replaced. So the x column values are going to be the same. So it's going to be 5, 2 for the x's. The y column values, those are the ones that are being replaced. So it's going to be -1, 2. Okay, so we have a 2 by 2 matrix. Go ahead, punch it in or freehand it. The choice is up to you. First cross product will give us 10, and then we subtract from it the other cross product. And if you need a refresher on how to find the determinants of 2 by 2 matrices, 3 by 3 matrices, or whatever order, go ahead, look at our earlier video. When I have time, I'll link it. Difference of 10 and -2 is 12. So we're going to tell world dy, or the determinant form, when we replace the y column values with the answer column values, gives us 12. So we know what the answers looks like, or how they should be. Okay, so where am I? Okay, so we have x equals dx over d. So x equals, what was dx? dx is -1, d is -19, and that simplifies to a 19th. How about y? So y equals dy over d. So that will give us dy is 12. D is, I need to highlight these because they're disappearing. Okay, d is -19. And then that's it, it's already simplified. Okay, so we found the x, we found the y. Original problem is a system, so let's go ahead, spit out that ordered pair solution xy, which is a 19th, and then -12 19ths, and then you could check it at your house. So that's my answer, and I'm sticking to it. Okay, so let's go ahead and knock out problem B. Okay, so problem B, we have a system in three variables. So let's go ahead and write down what the answer should look like if it even has a solution. So let's do this. So this is in from the top. We have a system of equations in 3 variables. So if it has a solution, it would be the following order triple: x, y, z. And the question is, how do we find them? So x is gonna be given by dx over d. So again, these are all determinants. Y is given by dy over d, and z is given by dz over d. Okay, so with that being said, whether we want to find x, y, or z, they are all being divided by d, which is the determinant form by the coefficient matrix. So again, if you want to save yourself some headache, verify that the determinant of the coefficient matrix is not 0, and if it isn't, then we have the green light to proceed. So let's go ahead and write down what d is. So d is given by the determinant of the coefficient matrix. So the coefficients in row 1 are 3, -2, 4. 3, -2, 4. Coefficients of row 2 is going 6, 5, -3. Coefficients of row 3 is 5, 3, 5. Now, if you have access to a graphing calculator, go ahead, take the green light and punch it in. If you don't have access to a graphing calculator, right now it's TI, remember, it's giving free access to the virtual calculator. And if you don't have access to that because you didn't register, then I guess you're free-handed. Okay, so we're gonna go ahead edit this. So remember, anything that we want to do with matrices, we gotta go to the matrix homepage. So that's how I speak. Okay, so we're gonna do second matrix. Okay, second matrix, and then we're gonna edit. Okay, now this is where I'm at a crossroads. How should I edit this? I almost want to say that I should edit this as matrix A, but I'm not going to. Why? Because we're going to find the determinants of 4 matrices. D is the first one, dx is another one, dy is the third, and dz is the fourth one if I know how to count. So in this case, I'm actually going to label this matrix as D. Why? Because when I think of x, y, z, the next 3 variables that come to mind are a, b, c. So it's going to be tougher. It's going to be easier on my eyes if I say a represents dx, b represents dy, and then matrix c represents dz. But it's up to you. You do what you got to do. Okay. And then I want to remind myself where I'm going to store this. Okay, so yeah, so if you don't take the recommendations, then please label it. The worst thing you can do to yourself is like have everything edited, have everything entered correctly, but then we get it wrong because we forgot what we stored where. Okay, so we're gonna save this matrix as matrix D. So we're already in matrix D. We're gonna hit enter. We have a 3 by 3 matrix. It's already there, and if the dimensions are not set, then you go ahead and fix it. Okay, so let's go ahead, enter the elements. So it's gonna be 3, -2, 4. So again, go ahead, use those texting skills that you do a lot. Or what is it, the new thing that kids are doing? I forget. Cool. All right, so now we want to find the determinant. So when we want the calculator to do something with matrices, we always go to the matrix home page. So let's go back, but there's no back key, at least not to my knowledge. So second matrix. Oh, I lied to you. We need to get out. We need to come to the home screen because I was gonna enter find the determinant of D, but it's gonna enter that wherever my cursor is. So my mistake. So let's get out of there. Now that we're at the home screen, let's go to the matrix page. So second matrix, and then we want the calculator to do some math for us. So let's go to the math tab. We select the first option. We want to find the determinant, hence the vertical bars. And we want to find the determinant of this matrix, whatever you saved it. If you saved it as A, then you do determinant of A. But I told you my piece why I saved it as D. So second matrix, and then we're going to spit out matrix D. Cool. And then that gives us 164. Okay, last time I checked, that is not 0. So that makes me happy. It makes me happy because it means that I have the green light to proceed. So let me go ahead, label these X column values, Y column values, Z column values. So make the following a little bit less intense. So let's go ahead find dx. So dx is the determinant form when we replace the X column values with the answer column values. So if you want to write down your X, Y, Z, go for it. If you don't need it, I don't need it. So the only one that we're replacing is the X column values, hence the dx, and we're going to replace it with the answer column values. Let me put this to the side. So the answer column values are 0, 7, and 11. Oh, that didn't look so nice. Okay, and then we're going to keep the Y and Z. So -2, 5, 3, and then 4, -3, 5. Okay, so with that being said, let's go ahead find dx. So let's find this determinant. Okay, let's go ahead edit this matrix, and we're gonna edit it under A, matrix A. The reason why I put where I save it is because let's go to the matrix window. Second matrix is because we don't have a matrix X, do we? Yeah, we don't. Okay, so yeah, that's why I write down how I'm gonna save it. So let's go ahead, edit it. So we have a 3 by 3 matrix. Cool. And then we're gonna edit it as matrix A, so it's already there. Make sure that you put the dimensions. It's a 3 by 3. Cool. And then that will get the elements are 0, -2, 4, 7, 5, -3, and then 11, 3, 5. Cool. Fantastic. So please confirm that you've entered it correctly. I think I did. So let's get out of here, okay? Because right now, if I tell the calculator to do the determinant, it's gonna enter that command right here. We don't want to do that. So let's get out of here. So second quick, then we're gonna find the determinant of this matrix. So determinant. So second matrix. Calculator, do some math for us. So math. Determinant, and then see where you entered this matrix. So according to my love notes, we started as A. So second matrix, and then matrix A, and then the calculator gives us 0. How about that? Okay. And then we can keep finding the rest, but with your permission, we're gonna find the X value now. Okay. So in this case, X, to find it, we're gonna take dx divided by d. So that will give us dx is 0, d is 164, and then that will give us that the value of x is 0. Let me go ahead, highlight it. Cool, fantastic. So what are we gonna do next? Same thing. Okay, so we have where am I? So we want to find dy. So dy is a determinant form when we replace the x when we replace the y column values with the answer column values. Okay, so let me go ahead, just put a highlighter right here. And again, if you want to put the x, y, z, go for it. If you don't need it, then I don't need it. Okay, so the answer column values, where am I? They are 0, 7, and 11. Cool. All right, and the x and z stay the same. So the x are 3, 6, 5, and the z is 4, -3, 5. Fantastic. Okay, so let's go ahead, edit this matrix, and we'll edit it as matrix we'll edit it as matrix B. Cool. All right, so let's go ahead, edit matrix B, and put these elements. Okay. All right, so second matrix. Oh, this is so repetitive. Yeah, I don't really this is not like my favorite technique. I myself prefer matrix inverses if I have access to a graphing calculator. Okay, so we're gonna edit it matrix B, put the dimensions. We got a 3 by 3 matrix, and let's go ahead, put those texting skills to test. Oh, I didn't do it right. 0, 4, 6, 7, -3. And remember, you can either use the side arrow or you can hit enter as you put the element. So make sure that you typed it in correctly. I think we did. Let's get out of here. Second, quit. And then we want to tell the calculator to calculate something for us. So let's go ahead, enter a determinant of this matrix. So second matrix, do some math for us. Find the determinant. Find the determinant of this matrix, which we stored as B or whatever you stored it as. So second matrix, enter B. And if we did this by hand, we would have gotten 328. Okay, so where am I? So the determinant is 328. And let's go ahead, then get the answer, okay, for y. So to find y, we're going to take dy and divide it by d. Okay, thanks to our hard work, we have that dy is 328. And then d, what was it, 164. You would think I know how to do this in my head, but I can't. So 328 divided by 164 gives us 2. Yeah, I should have known that. It's okay. It's like really late right now. Okay, so we found dy. What we need is dz, and that will allow us to find the value of z. So let's go ahead and do this. Dz, what is that? That is the determinant form when we replace the z column values with the answer column values. So let's go ahead and do this. So the x stays the same, 3, 6, 5. Let me go ahead and zoom out. Cool. The y stays the same, -2, 5, 3. The one that has to go is gonna be the z column values. So let me go ahead, highlight it, and the z column values we replace with the answer column values, which is 0, 7, and 11. Okay, so let's go ahead, find the determinant of this 3 by 3 matrix. Where should we store this matrix? I will probably go with C. Okay. Okay, so go ahead, speak to yourself, but again, you can store these wherever you like. So let's go ahead, edit it. Okay, this is the last one. So yes, so let's go to the matrix window. So second matrix, and then we're gonna go over to edit. We're gonna edit matrix C. It is a 3x3 matrix, so the dimensions are there, or adjust them, because you know we're not necessarily working together. Okay, sorry, I had a moment. The elements are 3, -2, 0, 6, 5, 7, 5, 3, 11. Okay, and let me just confirm to see if I did it correctly. All right, fantastic. So let's get out of here. So second, quit, and then calculator, do some math for us. Find the determinant of this matrix. So second matrix, do the math, determinant, and let's tell the calculator to find the determinant of this matrix wherever you stored it. In this case, I stored it under C. So second matrix, and then spit out matrix C. Fantastic. So let's go ahead, hit enter, and that gives us 164. Whew, I feel like I can breathe finally. Okay, so to find what was it, to find Z, let me get this out of the way. We're gonna find dz divided by d. Okay, according to our hard work, dz gives us 164, and d, according to our hard work, what was it? Also 164. So I'm not really good at arithmetic, but last time I checked, quotient of 164 in itself will give us 1. So after all that hard work, we find that x is 0, y is 2, and z is 1. So the solution is given by the order triple x, y, z. Okay, so so that will give us 0, 2, 1. Good, fantastic. So okay, I'm gonna go ahead, come to another problem. Give me a sec. Okay guys, so let's go ahead and knock out our third problem. I wasn't gonna do this problem because pretty much it's the same exact thing as we did earlier, but there's a special reason why we're gonna do it. Okay, so at a first glance, I would want to say like, maybe I can't use Cramer's rule to solve a system of equations, because I have to remind myself I can use Cramer's rules if and only if so let me just read it. So we can use Cramer's rule as long as there is the same number of equations as variables. So I'm like, this looks a little choppy, but let's look at our variables. Our variables are x, y, z. We have 3 variables, so we're expected to have 3 equations. We have 3 equations, so we're good. It would be nice if each equation had all 3 variables, but that's not a must. Okay, as long as we have the same number of equations as variables, then we're good. With your permission, we are gonna rewrite this because this is a little bit tough on my eyes. I would like to see the x's lined up, y's and z's. So let's go ahead and do this. So we're gonna rewrite this as x plus 3y. We don't have a z term, so we'll leave a space, equals -3, and then the second equation doesn't have an x term. It's okay. We have 2y plus z equals 3, and then the third equation we have -x, skip the y term, plus 3z equals 7. Fantastic. So again, we are going to solve this by using Cramer's rule. So we have a system in 3 variables, so if the system has a solution, it would be the order triple x, y, z, where x is found by finding dx and dividing it by d, y is found by finding dy, dividing it by d, and z is found by, you guessed it, finding dz divided by d, where all of these are determinants of certain matrices. Okay, so now I'm going to go ahead, do the setup, and then I'm going to give you the answers. Since there's no z term, then the coefficient of the z term is 0. So let me go ahead and insert my special effect 0. So for the second equation, since there's no x term, then the coefficient is also 0. So I'm going to go ahead and highlight the 0. The third equation doesn't have a y term, so you guessed it, the coefficient on the y is 0. So you don't really have to put plus 0. See, I need it for my peace of mind. With that being said, to find x, y, and z, they all involve dividing by d. So before I invest a lot of time in finding dx, dy, dz, love yourself and find d first. So that's the only one that we may do all together. So d represents the determinant form by the matrix coefficient or coefficient. Yeah, matrix coefficient. Yeah, so it's the matrix formed by the coefficients. So row 1, the coefficients are 1, 3, and 0. And row 2, the coefficients are 0, 2, 1. And then row 3, the coefficients are -1, 0, and 3. So -1, 0, and 3. Okay, with the little elbow grease with the calculator. I'm not just gonna show the steps because it takes time. Okay, but we put it into the calculator and the calculator gives us 3. Cool. So that does not equal 0, so that makes me happy, which means that we can use this technique. Dx, so it's the determinant form when we replace the x column values with the answer column values. I'm going to hold you accountable to that, so I'm going to give you some homework, and when we do, that will give us -24. Okay, dy, what is that? That is the determinant form when we replace the y column values with the answer column values. So if you want to put x, y, z, you know, to make things easier on the eye, go for it. But if you don't need this, then I don't need this. Okay, so again, for homework, that will give us, where am I? That will give us 5. Okay, and then I'm gonna give you homework to find dz. Okay, so dz, that is the determinant form when we replace the z column values with the answer column values. Okay, just look at what we did for the earlier video, and that gives us -1. Okay, so with that being said, we found dx, we found dy, we found dz. So let's do this. So where am I? I'm out of space. I'll do it right here. So to find x, we're gonna take dx and divide it by d. So dx, where am I? Dx is -24. Again, I need you to verify that for me with your calculator. D is 3, and that's gonna give us a -8 for x. For y, that's gonna give us a dy over d. Dy, again, I need you to verify that for me is 5 over d, which is 3, and that's it. You can't reduce it. Okay, what about z? Okay, z is given by dx. We're gonna divide it by d. Dx, again, I need you to verify for me. It's -1, and then value of d is 3. Okay, so if we had used another technique to solve this, well, we're supposed to use Cramer's rule, but assuming we had the green light to solve it however we like, we would have gotten the same 3 values. So we found the x, we found the y, we found a z. So the system has a solution, namely that order triple, which is -8, 5/3, and -1/3. Fantastic. So don't forget to always put your answer in exact form. You know, if you punch it into your calculator and you get a decimal, then work your magic to write it as a fraction. Okay, so I know that I pretty much gave you homework, so it kind of feels weird for us to do another problem, but you will be thankful when we do the other problem. So this will be our 4th and final problem, just as said. So same speech, we want to use Cramer's rule to solve a system of equations. So a system has 2 variables, so we're expected to have 2 equations. We have both. So let's go ahead and do this. So gentle reminder, to find x, we're going to find dx divided by d, and to find y, we're going to find dy divided by d. If you love yourself, before you find dx and dy, find d and confirm that it doesn't equal 0. If it equals 0, you know the speech, we have to use another technique. So d is given by the determinant of the coefficient matrix. So row 1 will be 4, -2. Row 2 will be 8, -4. And I forgot that I needed to update this problem, so this should be a -6 in order to get the answer that I'm looking for. So let's go ahead, find the determinant. So first cross product, that will give us -16, and we're going to subtract from it the other cross product, which is also -16. Last time I checked, difference of -16 and itself, that's a little bit hard on my eyes. So sum of -16 and 16 gives us 0, and that makes me really sad. Why? Because division by 0 is not defined. So in this case, because the determinant is 0, we can't use this technique. Why can't? Because we don't want the quotient to be undefined. So we have to use another technique. So let me go ahead and write it out. Yeah, sorry for that long pause. I know you missed my lovely voice. So how should we solve it? So we can solve by graphing. I lied. Don't do it by graphing. Substitution, elimination, or we can aim for matrix inverses. But I'm going to go the old school route. I'm going to go ahead try to solve it by substitution or elimination. If you remember me from earlier videos, you know that I'm a big fan of elimination. So we're going to go the elimination route. There's no rule that says that you're supposed to eliminate the x or the y. It's really a personal choice. What I do, I let the numbers tell me what to eliminate. So if I wanted to eliminate the x's, I know you like my special effects. If you wanted to eliminate the x's, what would the numbers have to look like? The least common multiple between 4 and 8 is 8, so I will need to work with 8. If I wanted to knock out the y's, the least common multiple between 2 and 4 is 4. So this is how I make the call. Do I want to work with 4 or do I want to work with 8? I feel like it's a no-brainer. Let's work with 4. So 4 is associated with y. So let me speak to myself. And the love notes, the least common multiple between 2 and 4 is 4. So in order for them to be opposite, then we need to fix it so one coefficient on y is positive 4 and the other one is negative 4. Luckily for us, we already have one of the desired coefficients. We just need to work on getting the positive coefficient. If I see this correctly, negative 2 times another negative 2 will give us positive 4. So let's go ahead and multiply the top equation by negative 2. So when we do that, will give us excuse me, that will give us negative 8x plus 4y equals 12. So remember, I had to change the original problem. I changed it to negative 6. Fantastic. So bottom equation was perfect, I guess. So we confirm that the coefficients of the desired variable are opposite. We have a positive 4y, we have a negative 4y. So now we can add the equations to eliminate the desired variable. But check it out, as you can see, the y didn't want to go out without a fight. Not only did the y's cancel out, the x's cancel out, and the constants cancel out. So we have nothing equals nothing, okay? We can't just leave it as a go. So we'll put 0 equals 0. So when we're solving the system of equations and the variables cancel out, we just need to pause right there and we ask ourselves, do we have a true or false statement? You know that I don't need to see this, but I do this for myself. So I'm crossing my fingers. I'm like crossing my fingers. Please let it be a false statement. Please let it be a false statement. But it's a lie. As you can see, 0 does equal 0. So unfortunately, it is a true statement. I say unfortunately because if the variables are out and we had a false statement, then the system would have no solution. But since the variables are out and we have a true statement, then yep. If the variables cancel out and we end up with a true statement, then that means that the system has an infinite number of solutions. Okay, so if we have a boatload of solutions, the question is, how are we going to express those ordered pair solutions? So we're going to have to introduce a parameter. So need to introduce a parameter. Okay, so that's just fancy talk for introduce a new variable. Okay, so you can use any variable of your liking with the exception of the ones you see on the screen, which is x and y. So you know my style, I like to use u. I think our book uses s, but my s's look like 5, so I use u. So let me go ahead and write down the system that we had, the original system, because I don't want to go up and down. Okay, so we are gonna start fresh. Okay, so let's go ahead and do this. So what we need to do, we need to write both x and y in terms of a parameter or new variable u. So what I need you to do is solve for x or y in any of these equations. Solve for x or y. So in any equation. So which equation catches your eye? I think the top one, because the numbers are smaller. Okay, so we have 4x minus 2y equals negative 6. Fantastic. And then we're going to solve for x or y. So let me write that again. Okay, so which variable should we solve for? It doesn't really matter. Okay, this is how I do it. If I were to solve for x, we would eventually have to divide both sides by 4. 4 does not go into 2 and 6, so we're going to have fractions. We have no time for that. If we were to solve for y, we would eventually divide both sides by 2. 2 goes into 4 and into 6, so check it out. No fraction, so no brainer. Let's go ahead, avoid the fraction computation and solve for y. So if you're not with the y term, you gotta go. The question is, what happens if we had solved for x, it's not a big deal. The expressions is gonna look different, but well, the interpretation will be the same. So when we subtract 4x from both sides, that will give us negative 2y equals negative 4x minus 6, or you can put the 6 first for all I care. To finish it off, to get rid of the times negative 2, let's go ahead divide both sides by negative 2. And that will give us with y equals 2x plus 3. So the book typically introduces the parameter right away, and they say, hey, let x equal u or let y equal u. To me, I feel like that's a little bit too premature, because it forces me to not to make things a little bit easier for me. So what I like to tell students is once you solve an equation for a variable, at this point now go ahead, tell yourself which one should represent u. Should we let x equal u or we let y equal u? Now when we introduce the parameter or the new variable, ultimately we want to write both x and y in terms of our new variable. So the question is, what should I let equal u? Should I let x equal u or should I let y equal u? And this is my take. We already have a nice expression for y. Okay, y equals this. So what I recommend, you let the other variable equal u. So we're gonna say let x equal u. Okay, so we want to write out both of our variables in terms of our parameter or our new variable u. We said let x equal u. Check it out. We already wrote one of these variables in terms of u. Now we need to write the other variable, namely y, in terms of u. But that's an easy fix. We already have an expression for y, so let's go ahead, plug and chug. So we say we have y equals 2 times x, but we had just said that x equals u, so let's substitute a u for x, and then we add 3. Okay, so we have an expression for x in terms of u, we have an expression for y in terms of u, or parameter. Okay, so we got it. Okay, so in this case, we have established that the system has an infinite number of solutions. So the question is, how are we going to write those ordered pair solutions? So we're going to say that the solution set is given by the set of ordered pairs u, x, y, which is 2u plus 3. Let's go ahead, put that in set builder notation. So we have the set of ordered pairs in this form, u comma 2u plus 3, such that, what's so special about u, it could be any real number. So such that u is any real number. And the question is, why do we have to write the answer in set builder notation? We have to write it in set builder notation because it's just the only way we can describe the solution set. This is how it goes down when the system has an infinite number of solutions. Okay guys, so this was our 4th problem. I said we were gonna do 4, so we're out. Thanks.